Hi, this is Mr. Woodbury from College of the Sequoias for my Math 21 class. Today we're going to go over the section 10.3. This covers the one mean test, and in addition we'll talk about its alternative test called the sign test. For the one mean test, when it comes to identifying the test compares the unknown mean of a population to a particular value, such as the mean age of all COS students is less than 24. The summary of the sample will include the mean, standard deviation, and size, or you could also have the exact set of data instead. Now, the data for this type of problem will be quantitative, numerical, not qualitative, categorical. Think about the question you would ask to gather the data. Think about the kind of answers you'd get back. Are they numerical or categorical? If they're numerical, we're probably talking about a one mean test. Let's talk about the differences from the previous test, the one proportion test. First, in step 1, we're going to use the symbol mu instead of the symbol p in both the null and alternative hypotheses. Step 2 is exactly the same, the level of significance. In step 3, the name of the test is the one mean test. In step 4, inside StatCrunch, we'll use stat, t-stats, one sample, and then either with data or with summary, depending on what you have. This is similar to the confidence intervals for a population mean. Now, for the conditions, we're going to assume that the data come from a random sample or a randomized experiment, but there are other conditions to check. If you only have summary information, then we'll make sure that the sample is no more than 5% of the population size, by checking that 20 times the sample size is not greater than the population size. If you have data in addition to that condition, we need to make sure that the set of data has no outliers. We can do this with a box plot, and we need to make sure that the data are normally distributed, and we can do that with a QQ plot in StatCrunch. If we're working with summary, we'll check the condition 20 times n less than or equal to n. We'll use stat, t-stats, one sample with summary. In the top of that box, we'll enter the sample mean, sample standard deviation, and sample size. We'll take the value from the null hypothesis and type it in to the null hypothesis for mu sub 0. And then we'll pick the correct sign for the alternative hypothesis. By the way, StatCrunch labels this as HA rather than H1. It's the same thing. The difference with data, after we verify that 20 times the sample size is not bigger than the population size, we'll check for outliers with the box plot, and we'll make sure the data are normally distributed with a QQ plot. We'll compare the correlation statistic from that graph to the critical value from the normality table. Instead of with summary, we'll use with data in StatCrunch. You'll pick the column that contains the data, you'll type the value in the null hypothesis, and again, select the correct alternative hypothesis. One quick note, all the data for examples 3 through 6 are located in the StatCrunch group under section 10.3. If you're not a member of the group, do a search for Woodbury, space, math, space, 21. Okay, let's begin with our first example. Example 1. A counselor at a community college claims that the mean GPA for students who have transferred to State University is higher than 3.0. A random sample of 45 such students had a mean GPA of 3.12 with a standard deviation of 0.31. Test the counselor's claim at the 0.05 level of significance. Okay, we're testing a claim, so we know it's a hypothesis test. We're comparing the mean for a population to a number, 3.0. That tells us that this is the one mean test. In addition, the sample information includes a summary with a sample mean, a sample standard deviation, and a sample size. We do need to check the conditions for this test. The only condition is that 20 times the sample size cannot be bigger than the population size. 20 times 45 equals 900 students. And we'll assume that more than 900 students have transferred to that university. The null hypothesis is of the form mu equals some number, and in this problem, we're comparing the mean to 3, so 3.0. The alternative hypothesis also compares mu to 3.0. Which sign should we use here? Well, the claim is that it's higher than 3.0. That indicates that we'll use the greater than sign. The level of significance is given in the problem as alpha equals 0.05. And we verified that this is the one mean test. For the calculations, we'll turn to StatCrunch. We need to make note that the sample mean is 3.12, the sample standard deviation is 0.31, and the sample size is 45. Also note the null and alternative hypothesis. Okay, let's go to StatCrunch. In StatCrunch, we'll begin by pressing Stat, T-Stats, one sample with summary, because we have a summary of the data, not the data itself. The sample mean we found was 3.12. The sample standard deviation was given as 0.31, and the sample size was 45. In the null hypothesis, we have that mu is equal to 3.0, so we type in 3.0. And for the alternative, we select the greater than sign. Click Compute, and there are the results. The test statistic rounded to 2 places is 2.60 with a p-value of 0.0064. We found that t, the test statistic, was equal to 2.60 and the p-value was 0.0064. We compare that p-value back to the level of significance. Since it's lower than the level of significance, we reject the null hypothesis. In other words, we're saying that we believe the null hypothesis is false. And when we reject the null hypothesis, that means that there is enough evidence or sufficient evidence to conclude that H sub 1, the alternative hypothesis, is true. In this case, that means that the mean GPA of all transfer students is higher than 3.0. Now for example 2. A recent TV show claimed that the mean age of women at their first marriage is 25. A random sample of 104 married females had a mean age of 22.4 years old at their first marriage, with a standard deviation of 4.63 years. At the 0.05 level of significance, test the show's claim. We're comparing the mean age of women at their first marriage to a number, 25. That indicates that we're looking at a one mean test. We'll still have to verify the conditions that this is true. In addition, we know that we have a sample size of 104, a sample mean of 22.4, and a sample standard deviation of 4.63 years, indicating a one mean test, one set of summary information for numerical data. Think about how you would gather this data. You would ask women how old they were at their first marriage. Your answer would be in a numerical form. So we have numerical data. To check the condition, 20 times the sample size can be no more than the population size. We'll multiply 20 by the sample size of 104. That's 2,080 married women, or women who have been married. Are there more than 2,080 women who have been married? Of course there are. So that means that the condition is met, and we can begin this one mean test. We're comparing the mean to 25, so the null hypothesis is mu equals 25. For the alternative hypothesis, we're also comparing mu to 25. Is there an indication in the problem that the mean is higher than 25? Lower than 25? No, it's simply that it is 25. When there's no indication of higher or lower, the alternative hypothesis defaults to not equal to 25. The level of significance is given in the problem as 0.05, and for step 3, we do have the one mean test. When we go to StatCrunch for the calculations of the test statistic and the p-value, note that the sample mean x bar is 22.4. The sample standard deviation S, that's 4.63, and the sample size N is 104. Also remember the null hypothesis is mu is equal to 25, so we have to change that value. And the sign for the alternative hypothesis is not equal to. So we'll have to make sure we have the right sign. Let's go to StatCrunch. Again, because we're using summary, we'll start with stat, t-stats, one sample with summary. The sample mean in this problem was 22.4. The standard deviation was 4.63, and the sample size was 104. The null hypothesis was mu equals 25, and the alternative was already set up as not equal to 25. Press compute. Our test statistic t is negative 5.73 with a p-value that's less than 0.0001. The test statistic is t equals negative 5.73, and the p-value we're told is less than 0.0001. That's StatCrunch's way of saying that this is really small. Getting a sample like this would happen less than 1/10,000th of the time. We compare that p-value to the level of significance, and it's clearly lower than that. So when that happens, we reject the null hypothesis, and we're saying that we feel the null hypothesis is false. When you reject the null hypothesis, that means that you do indeed have enough evidence to conclude that the alternative hypothesis is true. In this case, that means the mean age of all women at their first marriage is not 25. Remember that this is supposed to represent the alternative hypothesis, and mu not equal to 25 means that the mean is not 25. So we don't necessarily use the wording in the problem. We use the wording that goes along with H sub 1, the alternative hypothesis. When you see the not equal to sign, be very careful with the wording of your alternative hypothesis. Now for an example of a problem where we're working with data rather than a summary of data. These are the number of packages handled by a shipping office on 17 randomly selected days. Test the claim that the shipping office handles more than 1,200 packages per day at the 0.01 level of significance. So this appears to be a one-mean test. We're comparing the mean to a number, 1,200 per day. We have to check the conditions. The first condition we're checking is that 20 times the sample size is not bigger than the population size. 20 times 17 is 340 days. And we're going to have to assume that this shipping company has been open for more than 340 days. Now we have to check to see if there are outliers and if the data are normally distributed. And we'll do that using two graphs in StatCrunch, the box plot and the QQ plot. Okay, so the worksheet I have open is section 10.3. That's from the Woodbury Math 21 group. And I'm going to be working with column 1 where it says 3 packages, for example 3. I'm going to start with a box plot. That's under graph, box plot. Pick the column, packages. We're going to use the fences to identify outliers, and also we're going to draw the boxes horizontally. Press compute. We see no outliers, so that means that we can go on and make sure the data are normally distributed. We can do that by pressing graph, QQ plot, pick the column packages, add the correlation statistic, and it's a good idea to select normal quantiles on the y-axis. This is because when you're working in MyLab and they ask you to match the graph of your QQ plot to one of the 4 in the problem, that's the way that they're going to be graphed there. Click compute, and we see that the correlation statistic is 0.959. We have a sample of 17. Is that big enough to say that the data are normally distributed? Well, let's take a look at the table. For a sample size of 17, the number to beat was 0.944. Again, looking at our graph, the correlation statistic was 0.959, greater than 0.944. Therefore, the data are normally distributed. And all the conditions are met. Okay, now that we know that the conditions have been passed, this is a one-mean test. The null hypothesis is that mu is equal to 1200. What sign do we use in the alternative hypothesis? Well, it says that more than 1200 packages per day, so we'll use mu is greater than 1200. The level of significance given in the problem is 0.01, so we write alpha equals 0.01. And for step 3, this is the one mean test. Now for the calculations, again, these values have already been entered in StatCrunch for you. Look for the file named section 10.3. And again, if you're not part of that group, search for Woodbury Math 21 with spaces between Woodbury and Math and 21. And you can do that inside of StatCrunch in the groups page. Let's go to StatCrunch and go ahead and do the computations. Okay, to compute the test statistic and p-value, press Stat, T-stats, one sample, and this time with data, because we have the actual data to work with. Pick the column, packages. The null hypothesis was that mu was equal to 1200. The alternative was mu is greater than 1200, so change the sign, press compute. There's our t-stat, our test statistic is 3.33, rounded to 2 places, with a p-value of 0.0021. We found that the test statistic t was 3.33, and the p-value was 0.0021. That is less than the level of significance, so that tells us to reject the null hypothesis. We're saying we believe it's false. And whenever we reject the null hypothesis, that means that there is sufficient evidence to conclude that the alternative hypothesis is true, namely here that the mean is more than 1200. So in this problem, that means that the mean number of packages is more than 1200 per day. Now we'll move on to the sign test, which is an alternative to the one mean test that we use when the conditions are not met. Let's discuss that. If the conditions for the one mean test are not met, meaning that either you have an outlier or the data are not normally distributed, one alternative test that we can perform is called the sign test. The sign test is known as a non-parametric test, and that means that it requires no assumptions about the data. We'll begin by rewriting the test in terms of the population median, M, instead of the population mean, mu. So this is a slightly different test than a one mean test. It's a one median test. If we're going to do this by hand, what happens is that we assign each value that's greater than the claimed median a plus sign, and each one that's smaller than the median a minus sign. The test statistic is determined by the number of plus signs and minus signs, and there's a critical value that's used to determine whether to reject the null hypothesis or not. However, we're going to do this in StatCrunch, and it's going to generate a p-value for us just like the one mean test. Let's talk about the differences from writing up the one mean test. First, in step 1, the null and alternative hypotheses need to be stated in terms of the population median, M, and not the population mean, mu. So the null hypothesis will be of the form M is equal to some number. In step 3, this is the sign test for one median, or as we'll simply write it, the sign test. In step 4, in StatCrunch, to find this, this is under Stat, Non-Parametrics, Sign Test. When you get in there, you'll select the column that contains your data. You'll enter the appropriate value for the population median and the null hypothesis, and you'll pick the right sign for the alternative hypothesis, just like the one mean test. Finally, when we get to the conclusion in step 5, every place where you would have written the word mean, you'll replace it with the word median. Let's take a look at an example. Example 4. An experimental algebra exam is given to 20 randomly selected college algebra students. Their scores are listed. Test the claim that the mean score for all college algebra students on this exam is below 60. Use alpha equals 0.05. We have a set of numerical data, and we're comparing a mean to a number, 60. That indicates that we're looking at a one mean test. The null hypothesis would be mu equals 60. The alternative will be mu less than 60 because we're looking for below 60. We need to check the conditions. 20 times n is 20 times 20, or 400 students. Are there more than 400 college algebra students? Yes, there are. So that condition is met, but we still have two more conditions to check because we're working with data. We need to make sure that there are no outliers and that the data are normally distributed. Let's go ahead and go to StatCrunch. We'll begin to check the conditions by making a box plot for the column scores. Press Graph, Box Plot. Select the column scores. We'll make sure the fences are going to identify the outliers, and I'm going to draw the boxes horizontally like I normally do. Press Compute, and we see a couple of outliers here. 14 and 15 are both outliers. That means that the conditions are not met, and we're not going to perform a one mean test, but instead the sign test for one median. So we found that both the numbers 14 and 15 were outliers. That tells us that we cannot perform a one mean test, but instead this is going to be the sign test. The null hypothesis changes to m for median equals 60, and the alternative will be m is less than 60. The level of significance is given as alpha equals 0.05, and the name of the test is the sign test. Let's go back to StatCrunch to do the calculations. All we're looking for is the p-value. To compute the p-value for this sign test, press Stat, Non-Parametrics, Sign Test. Pick the column Scores. The null hypothesis is now that the median is equal to 60, and the alternative sign was less than. The median is less than 60. Press Compute, and there's our p-value, 0.6762. Okay, we found that the p-value was 0.6762. That's a really high p-value, definitely greater than 0.05. That indicates that we are unable to reject the null hypothesis. So we will fail to reject the null hypothesis, and when that is done, we're saying that we cannot prove that it's false. When we do that, that means that there is not enough evidence to conclude that the alternative hypothesis is true. In this case, we say there is not sufficient evidence to conclude that the median score for all college algebra students is below 60. This is a direct translation of the alternative hypothesis. The median, m, is below less than 60. Okay, here's example 5, and we're unsure whether this is going to be a one mean test or a sign test. We'll figure that out. A national report claimed that the mean credit card debt of college students is higher than $1,200. Here are the amounts of credit card debt for 20 COS students. Use the data to test whether the mean debt for COS students is also higher than $1,200 at the 0.05 level of significance. There are three conditions to check. This appears to be a one mean test. We're comparing the mean of a population, COS students, to a number, $1,200. For the first condition, 20 times n is 20 times 20, or 400 COS students. Are there more than 400 COS students? I would say so. There are somewhere near 16,000, so that condition is met. Next, we'll have to check for outliers with the box plot and whether the data are normally distributed with a QQ plot. Let's go ahead and do that. We'll begin by testing the conditions first to determine whether there are any outliers. Press Graph, Box Plot. Select column 5, Debt. Make sure the fences are going to show us the outliers. I clicked on Draw Boxes Horizontally, press Compute. Notice that there are no outliers. Next, let's make sure that the data are normally distributed. Press the Graph button, and this time select QQ Plot. Select Debt for column 5, add the correlation statistic, and select the other option to put the normal quantiles on the y-axis. Press compute. The data are roughly linear here. The correlation statistic is 0.987. Our sample size was 20, so let's turn to the table of critical values. For 20, that's 0.951. Returning to the graph, 0.987 is greater than 0.951, therefore the data are normally distributed, and we can go ahead and do this as a one mean test. Both conditions were true, no outliers, and the data are normally distributed, so this is a one mean test. The null hypothesis is of the form mu equals. What number are we claiming the mean to be the same as? 1200. For the alternative, we'll also compare mu to 1200. What sign will we use? We're going to use the greater than sign because we're saying that it's higher than $1,200. The level of significance is given in the problem as alpha equals 0.05, and the test is the one mean test. For the calculations, let's return to StatCrunch to use that data along with our null hypothesis mu equals 1200 versus the alternative mu is greater than 1200. To compute the test statistic and p-value, press stat, tstat, one sample with data because we have the data. Pick the column, det. The null hypothesis in this problem was mu equals 1,200. The alternative was that mu was greater than 1,200. Press compute. There are the results. The test statistic is 2.70 for t, and the p-value 0.0072. We found that the test statistic is 2.70, and the p-value here was 0.0072, which is less than the level of significance. That tells us that we will reject the null hypothesis and will conclude that there is sufficient evidence to conclude that the alternative hypothesis is true. In this problem, that's that the mean debt for all COS students is higher than $1,200. The mean mu is higher than, greater than, 1,200. Here's one last example where we're not sure whether this is a one mean test or a sign test. Example 6. Test the claim that the mean weight of an NFL lineman is above 300 pounds at the 0.05 level of significance. Here are the weights of 30 randomly selected NFL linemen. Okay, so it appears to be a one mean test because we're comparing the mean weight of an NFL lineman to a number, 300 pounds. But we need to check the conditions. First, 20 times 30 is 600 linemen. Now, you may not know enough about the NFL to say whether there are more than 600, but if we consider the population of people who could be an NFL lineman, there are definitely more than 600 of those. Also, if we go into history, we'll find that there are more than 600 as well. So we can go with that condition as being true. However, we still need to check for outliers and whether the data are normally distributed. We can do that in StatCrunch. Let's go ahead and do that. Let's check the conditions. First, we'll check to see if there are any outliers. Press graph, box plot, select column 6, NFL. We'll use fences to identify the outliers, and we'll also draw the boxes horizontally. Press compute, and we see there is an outlier. 242 pounds is an outlier here. That means the conditions are not met, and we're going to have to use the sign test instead. Okay, we found that there was an outlier, so this condition fails. The weight of 242, right here in the second row, is an outlier. That means that we cannot do the one mean test, but instead we will perform the sign test. In the sign test, we start with the null hypothesis of M for median equals, and here it's going to be 300. What sign will we use in H1? We're going to use greater than because we're seeing if it's above 300 pounds. So the alternative hypothesis is M is greater than 300. The level of significance is given in the problem as alpha equals 0.05. And as I mentioned, this is the sign test. So we're going to go to StatCrunch. The things that we need to know are the null hypothesis, m equals 300, and the sign for the alternative hypothesis, greater than. Let's go back to StatCrunch. To do the calculations, press Stat, Non-Parametrics, Sign Test. Select column 6, NFL. The hypothesis test, the null hypothesis, was m equals 300. The alternative hypothesis was that the median was greater than 300. Press Compute, and there are the results. Our p-value, 0.0261. Again, we're not going to write the test statistic for an alternative test, but the p-value works out to be 0.0261. And when we compare that to the level of significance, it's less than 0.05. So we will reject the null hypothesis. We're going to say that our assumption that the median is 300 is false. And that means that there is sufficient evidence to conclude that H1 is true. Or that the median weight for all linemen is above 300 pounds. Notice that I changed mean to median because we're performing the sign test, and the alternative hypothesis is in terms of the population median, M.